find how much money needs to be deposited now, so now, into an account to obtain $1,000, that's the future value, in 9 years. You want that in the future, in 9 years. If the interest rate is 7% per year, compounded daily, 365 times a year. Okay, so this one is it's not continuous compounding. It's compounded daily. So we have two formulas. So we use A equals P e to the RT for continuous compounding, but that's not this problem. This problem, so we're not going to use that because we don't have continuous compounding. Any other kind of compounding, we use A equals P 1 plus R over N to the NT. So for all other compoundings, meaning, let me get rid of that, clean that up. So for all other compoundings other than continuous, that is. So for continuous compounding, we use the PERT formula. For all other compoundings, we use this formula. So you want to have those in your notes for the exam. So let's plug in the information we need here. So they're saying find out how much money needs to be deposited now. So the now is the P. So we don't know the P. We're trying to figure that out. To obtain $1,000 future value. That's what the A is. The A is the amount in the future. The P stands for principal invested at the start. The R is the rate. The N is the number of compoundings per year. So N equals 12 if it's monthly, if it's compounded monthly. N is 2 if it's compounded semi-annually. Semi-annually means twice a year, every half a year. And monthly is 12 times a year. N is 365 if it's compounded daily. That's our situation here, compounded daily. And then so the rate is R, and the last one, T, is the time in years. Okay, so there's the information. We're going to plug stuff in now. So the amount, they're telling us the amount is $1,000. That's the future value. So that 1,000 goes right over here. They're giving us the A. We don't know the P. The R, the interest rate is 7%, so 0.07. Over N. N is the number of compoundings, which is 365 because we're compounding daily. So the N goes there, and then the N also goes up here, 2 places, times the T, and the T, number of years, does it say? Oh, there it is, 9 years. So 9 years. So there we go. There's our formula. We're trying to solve that for P. So the first thing to do is to multiply up here in the power zone with our calculator. So multiplying up there in the power zone, 9 times 365, I'm getting 3285. So 3285, there we go. So now we can solve this equation for P. How do we solve for P? We have to divide both sides by the same thing. Divide by the 1 plus 0.07 over 365 to the 3285 power. Divide by 1 plus 0.07 over 365 to the 3285 power. Cancel, cancel. So P will equal, now we have to put that in on the calculator. Let me help you with how you type that in exactly. So you're going to have to type in 1,000 on your calculator, divided by, and then you're going to have to do a parenthesis. In fact, why don't I just go back and make that parenthesis a different color, just for clarity, and then 1 plus 0.07, I can tell I'm going to run out of room here, divided by 365, and then you're going to have to close that parenthesis. I just made them a different color for emphasis. To the power. Now that's an up arrow, or maybe it's an X to the Y button on some calculators, or an X with a blank on some calculators, whatever your power button is, to the power 3285, and hit equals. So I'll do that also. And I'm getting 532, and all this is what P is going to be. So P, the principal is 532.62. Meaning that's the amount of money that should be invested. If you go back, that's the answer. That's the amount of money that should be invested at the start, right here. That's the principal that should be invested, that will grow to become $1,000 in 9 years. That's impressive, isn't it? $532.62 will grow to become $1,000. You'll gain almost $500 in 9 years if you just invest it and leave it at 7% compounded daily. It'll grow to become $1,000 in 9 years. You get free $500 about. There we go.